Okay, so we'll look at the vegetation again. We looked at it in the atmospheric circulation to show that where there is sinking air, there will be high pressure, no rain, clear skies, no clouds, and hence deserts. Whereas when winds come together and they rise, expand, cool, clouds form, and rain happens. So we looked at this last time. So we looked at the seasonal cycle, which we'll do again. So you can see that the ocean chlorophyll depends on the season, because as the sun comes up, light becomes available, then the near surface phytoplankton have enough light, nutrients, and CO2 to bloom. Actually, CO2 in the ocean is never really a limiting thing, because there is a lot of CO2 dissolved in the oceans. So if we look at it again, what I was trying to point out in the last temperature plot is that if you look around Galapagos, which is here the small red dot, you can see that the chlorophyll bloom is also very strong, and it has a very strong seasonality. Unfortunately, yeah, you can see the timing here, and you can see January, December as the time, and you have land vegetation shown as a vegetation index, and ocean chlorophyll shown as milligrams per meter cube. Okay, so you have to follow closely when the when the this is tricky because the animation is coinciding with the slide change as well, so I have to do it this way. So you can see that this is anchored to the equator. It doesn't go north and south like the blooms do here or the vegetation does here. Why? Because the trade winds are going back and forth. As you will see, we saw that the ITCZ goes back and forth with the sun. It doesn't cross the equator in some places because of some complicated land ocean dynamics and energy transport and so on and so forth that you are too young to learn right now. But you already know that no matter what you do, if you try to push water to the west on the equator, you're going to push it to the north of the equator, to the south of the equator. So on the equator, you're always going to have water coming up, cold water coming up, nutrients coming up, and as we said in the temperature plot, the temperatures are colder in the summer month because that's when the trade winds get very strong. The ITCZ in the north gets very strong. Sorry, the trade winds get strong in the southern hemisphere and push into the northern hemisphere and so on. If you don't understand the details, don't worry about it. But the other funny thing is we have the deserts in the ocean, as we said. So these blue regions in the oceans are, you can see the blue and purple regions here have low chlorophyll. The green, yellow, and red have high chlorophyll. So there are regions with high chlorophyll. There are regions which appear to have very high chlorophyll in certain seasons. So you can see the spring season here is a big bloom. It's called the spring bloom, and similar spring bloom happens in the austral spring on this side. And there are some very, very nice stories. Many animals, many birds, many big whales travel following these seasonal transitions. The wildebeest go back and forth here with the season in Africa, and there are some whales which go all the way from the North Pacific here across the equator all the way into the Southern Ocean, because when the Southern Ocean spring bloom happens, there are these little creatures that look like shrimp. They are called krill, and these whales actually go there and they have babies, and the babies actually eat krill because krill is a very, very nutritious food for them. Just like human beings, the lower in the food web you eat, vegetables and fruits and so on versus meat, right? You per unit of weight, let's say 1 kilogram of food, you will get more nutrition at the lower level than at the higher level. There are details about proteins and this and that and the other thing, so I don't want to make it complicated, but just remember that there are huge migrations of animals on land like the wildebeest, and fish and mammals in the ocean like the whales and the dolphins and the tunas and so on, that follow food and they lay their babies in certain places because that's how they have evolved, and so on and so forth. So you can remember this. Come summer months, you can see there is upwelling, very cold temperatures compared to the west, so you get 20, 22, 23 degrees here compared to 28, 29, 30 degrees on the western side. Similarly, you have strong upwelling happening, blooms for the phytoplankton, blooms happening. And remember that phytoplankton are eaten by the zooplankton, which are heterotrophs, or they eat food produced by the phytoplankton just like we do. And phytoplankton is eaten by zooplankton, then zooplankton is eaten by some small fish, and the small fish are eaten by the bigger fish, and the bigger fish are eaten by the even bigger fish, and so on and so forth. So there is a food web or a food chain in the ocean, and we catch certain fish. Of course, everybody loves salmon and tuna, and we protect the dolphins. They are not supposed to be eaten. Whales are hunted by some cultures like Norwegians and Japanese, and the world is trying to tell them don't kill the whales because there are such a small number of them, but they argue that it's their culture for centuries, so they must eat whales, and so on and so forth. And of course, countries go all around the oceans catching fish. Let's say in the Indian Ocean, ships from Spain, from Japan, from China, from India, from the US come here to catch fish. Similarly, a lot of fish are caught over here, a lot of fish are caught over here, and so on and so forth. So you can follow up on how human beings are fishing in the ocean and creating lots of problems as well. Okay, so just look at the animation again, how the seasonal cycle of rain produces deserts, rainforests, deserts in the ocean, deserts on land, phytoplankton blooms in the ocean, and remember also that CO2 is taken up when blooms are happening in the ocean or on land, right? So ocean is also able to take up CO2 through photosynthesis. Question is how much is dissolving directly into the water and how much is being taken up by the biology. Okay, so they are called solubility pump and biological pump and so on. If you're too young, then don't worry. One other thing you may want to notice, that Bay of Bengal is not as green as the Arabian Sea. So you will see that here the Arabian Sea gets very, very red and green. Bay of Bengal doesn't get so red or green because this is colder temperatures, because this has a strong boundary current called the Somali current, and you can use your Coriolis. If the currents are going north, then Coriolis will push it to the right of the direction of motion in the northern hemisphere. So if you push waters away from the coast, again you will bring cold waters. So you will again see that you have strong blooms here during the summer months when the strong Somali current is going north. So you can see this explosion of red colors along the coasts here, which is also very strong fishing ground. So the physics, the chemistry, the biology, winds, rain, everything is related in this Earth system, which is why we call it one system. So we'll come back and look at rain in the next animation, which again allows me to re-emphasize some of the points, allows you to listen and learn some of the points again and solidify the concepts in your head. Plus these are cute to look at anyway, right? So see you in the next podcast with the animation of the rain.